How accurately can you calculate the number pi using only Excel formulas and functions? This short presentation will show you how. To start, let's understand the circle function on the x-axis and y-axis. This function defines a circle using a center point and a radius, which is the distance from the center to the circle's edge. In this example, the center is at 1, 1, and the radius is 1. Here, the center is at 2, 2, and the radius is 2. The term r squared 2, r being the radius, equals 4 in this example. In this example, the center is at 5, 5, and the radius is 5. To calculate the area of a circle, use an inequality, less than or equal to, instead of an equality, equal sign, to ensure all points inside the circle are included. You can estimate the circle's area by counting the squares that fit entirely within it. Counting the squares entirely within the circle, in this case 81, helps establish the relationship between r squared 2 and the circle's area. Dividing the square count by r squared 2 provides an approximation of pi. Larger circles yield more accurate approximations of pi because they minimize edge effects, where partial squares at the boundary distort the calculation. A larger circle also aligns better with the grid, improving the precision of the area estimate. Excel cannot directly draw circles but can approximate them using a circle function and counting the cells within the circle. Let's explore how to create these functions and determine the maximum circle size Excel can simulate. To find the x-coordinate in Excel, use the column and indirect functions. Similarly, use the row and indirect functions for the y-coordinate. The -1 adjusts for the absence of column and row 0 in Excel. Apply the circle function in Excel using an if statement. Assign a value of 1 to cells within the circle and false to those outside. Replace x with the column indirect function and y with the row indirect function. The full function is shown below for use in the next steps. Enter the function in cell A1 and drag the fill handle down to A11. Then, extend it to the right up to column K, covering the range A1, K11. First, count the number of squares with a value of 1, representing cells within the circle. Next, divide the square count by r square 2, here 25. This yields an approximation of pi as 3.24, close to the true value of 3.14, but slightly off. Now, expand the circle to a radius of r equals 100 and r squared 2 equals 10,000. The grid, spanning A1 to GS201, contains 31,417 squares within the circle. This results in a pi approximation of 3.1417, accurate to 4 decimal places. Next steps, try creating even larger circles in Excel to test how accurately you can approximate pi. Excel's largest column is XFD, corresponding to column 16,384. This means you can work with a grid up to 16,384 times 16,384 cells. However, when I attempted to apply a function across this massive field, my computer couldn't handle it and crashed. Take on the challenge and see how far you can push the limits. Have fun exploring and experimenting.